On today's episode, NASA discovers something on Mars that could rewrite biology textbooks, while China reveals a master plan to explore the entire solar system. ESA scrambles to save their Mars mission, while Europe's newest rocket has an unexpected and explosive return to the launch pad. NASA has found something extraordinary, and it involves the largest organic molecules ever detected on the red planet. These aren't just any molecules. They might be fragments of ancient cell membranes from a time when Mars could have harbored life. But here's the thing. This discovery comes at the worst possible moment for the American space program. China has a new strategy, and it spans from the toxic clouds of Venus all the way out to the frozen moon of Neptune. Most of this sounds ambitious but achievable. Some of it sounds like pure science fiction that somehow might actually happen. The Chinese recently created something called the Deep Space Exploration Laboratory. The purpose? To unify and strengthen China's approach to conquering the solar system. This laboratory brings together China's National Space Agency and the University of Science and Technology of China, pooling resources and expertise for an unprecedented push into deep space. Now we know China has been incredibly active lately. They achieved the first-ever soft landing on the lunar far side with Chang'e 4. They brought back samples from the moon's far side with Chang'e 6, something nobody else has done. And they successfully landed and operated the Zhurong rover on Mars, making them only the second nation after the USA to achieve this. So they're not coming to this as rookies. They've got serious credentials and momentum. Here's their roadmap, and trust me, you'll want to hear this. 2028. The Tianwen-3 mission launches to Mars. This isn't just another rover, it's a sample return mission. They'll collect Martian soil and rocks, launch them back into orbit, and return them to Earth. This would be the first successful Mars sample return in history. NASA's been trying to figure this out for years. Costs keep ballooning, timelines keep slipping, and here comes China saying they'll do it in 4 years. Unless, of course, Elon Musk swoops in with a starship and just scoops up some dirt with a shovel, which honestly isn't out of the question anymore. 2029. Tianwen-4 heads out to Jupiter, specifically targeting Callisto, the most heavily cratered object in our solar system. This is fascinating because it creates a coordinated exploration scenario. NASA's Europa Clipper will be studying Europa looking for signs of life in its subsurface ocean. ESA's JUICE probe will primarily investigate Ganymede, the largest moon in the solar system, and China will explore Callisto. That gives us simultaneous up-close studies of 3 of the 4 Galilean moons, leaving only volcanic Io as the odd one out. It's like a scientific siege of the Jovian system. 30 Po, this happens on Earth, but it's crucial. China plans to build a large ground-based habitat to simulate long-duration spaceflight. Think of it as a Mars and Moon base simulator. A place where they can test life support systems, psychological factors, and operational procedures. Basically, they're building a practice Mars base in the Gobi Desert, or somewhere similar. 2033. Now things get wild. A mission to Venus that will return samples of the atmosphere to Earth. Let that sink in. Venus, where the surface pressure would crush you like a submarine at the bottom of the ocean, where it rains sulfuric acid, where the temperature could melt lead. They're planning to fly through that atmosphere, collect samples, and somehow return them to Earth. The engineering here is mind-boggling. Maybe they deploy a balloon that floats at a safe altitude, or use a diving glider that swoops down, inhales some atmosphere, then rockets back to orbit. This is the first legitimate Venus sample return mission I've ever heard proposed. 2038. Establishment of an autonomous Mars research station. Not humans, robots. A fully automated base studying in situ resource utilization, essentially teaching robots how to live off the land on Mars. Extract water from the soil, produce fuel from the atmosphere, maybe even start 3D printing structures. It's probably very similar to what China plans with their International Lunar Research Station, laying the groundwork for eventual human exploration. 2039. The absolute moonshot, pun intended. A mission to Neptune's largest moon, Triton. But not just an orbiter or flyby. They want to include a subsurface explorer for Triton's ocean. Just like Europa and Enceladus, we believe Triton has a liquid water ocean beneath its icy shell. But we have no idea how thick that shell is. The assumption that we could drill or melt through it and drop some kind of submarine probe into an alien ocean, that's ambitious beyond belief. The mass limitations alone for sending drilling equipment that far into space would require revolutionary propulsion, probably nuclear-powered. But if anyone told you 15 years ago that China would have a rover on Mars and samples from the lunar far side, you'd have called that ambitious too. This roadmap drops at a moment of maximum drama for NASA. They're staring down potentially catastrophic budget cuts. We're talking about programs being canceled, missions being scrapped. They still don't have a confirmed administrator. The Artemis program to return to the moon is stumbling badly, with delays and cost overruns that make senators reach for their red pens. Their own Mars sample return mission is currently being rebuilt from scratch with international and commercial partnerships because the original plan became too expensive and complex. But here's the incredible thing. Despite all this chaos, NASA is still doing absolutely groundbreaking science on Mars right now. What they've just discovered with the Curiosity rover has the potential to completely transform our understanding of life in the universe. Let me give you context. Curiosity isn't the new hot rover. That's Perseverance. Curiosity is the veteran, the old reliable. Launched in November 2011, landed in 2012, this car-sized, nuclear-powered tank of a rover has been methodically exploring Jezero Crater for over a decade. 6 wheels, a full suite of scientific instruments, and the patience of a geologist with unlimited time. Recently, Curiosity drilled into a mudstone rock called Cumberland, a 3.7 billion-year-old time capsule from when Mars had lakes and rivers. What it found inside has scientists losing their minds. Organic molecules. But not just any organic molecules, the largest and most complex ever detected on Mars. We're talking about molecules called decane and dodecane. Now, if you're not a chemist, those names mean nothing. But here's why they matter. Decane has 10 carbon atoms chained together. Dodecane has 12. These are long-chain hydrocarbons, and on Earth, molecules like these form fatty acids, the fundamental building blocks of cell membranes. Every living cell on our planet is wrapped in a membrane made from molecules like these. Think about what this means. We're not looking at simple methane that could come from geological processes. We're looking at complex organic chemistry that, on Earth at least, is associated with biology. These molecules were preserved in mudstone for 3.7 billion years, from a time when Mars was warm and wet, when it had a thick atmosphere and magnetic field, when it was, frankly, a lot like Earth. Now, NASA's being careful here. Organic molecules don't automatically mean life. These compounds could have formed through non-biological processes. Maybe they came from meteorites, or formed through chemical reactions between water and rock. But, and this is a huge but, they're exactly the kind of molecules you'd expect to find if microbial life once existed in those ancient Martian lakes. Meanwhile, across the Atlantic, Europe refuses to give up on Mars despite a frankly brutal history. Let's be honest about ESA's track record here. Beagle 2 in 2003 crashed. Well, actually, it landed successfully, but failed to deploy properly, which is somehow worse. Schiaparelli in 2016 crashed, and this time we watched it happen in real time. The pressure on their next attempt is immense. The ExoMars mission, featuring the Rosalind Franklin rover, was supposed to launch in 2022 with Russian cooperation. Then Russia invaded Ukraine, partnerships collapsed, and suddenly ESA had a rover without a ride and without a landing platform. But instead of giving up, they're rebuilding. Airbus is stepping in to construct a new landing system. NASA, despite its own budget troubles, is providing the launch vehicle and crucial heating units for the Martian surface. The new target, December 2028, right when China plans to be collecting samples. But if you want a reminder of just how hard space exploration really is, Europe just provided a spectacular example. Isar Aerospace, a German startup, attempted to launch their Spectrum rocket from Norway. This was supposed to be the first orbital launch from mainland European soil, a historic moment for European space independence. The rocket lifted off beautifully. For about 50 seconds, everything looked perfect. Then it started to wobble. Just a little at first, then more violently. The oscillation grew worse. The rocket flipped completely upside down, and the flight termination system activated. The rocket crashed back to Earth in a massive fireball that lit up the Norwegian sky. Here's the thing, though. Isar Aerospace called this a success. Not the explosion part, obviously, but they collected invaluable data. The flight termination system worked perfectly, preventing the rocket from flying off course. The launch pad survived intact. They learned exactly what went wrong and how to fix it. This is what space exploration looks like. Spectacular failures that teach you how to succeed. So here's where everything converges. 2028 is shaping up to be the most important year in Mars exploration history. China's Tianwen-3 will attempt the first Mars sample return. ESA's Rosalind Franklin will finally get its chance to search for biosignatures. NASA's Perseverance will have collected dozens of samples, waiting for someone, anyone, to pick them up and bring them home. But the real prize isn't just bringing back rocks. It's answering the question that's haunted humanity since we first looked up at that red dot in the sky. Was there ever life on Mars? NASA's discovery of these complex organic molecules raises the stakes enormously. If decane and dodecane really are remnants of ancient Martian cell membranes, then every sample return mission becomes potentially historic. China could bring back evidence of alien life. ESA's Rover could find biosignatures in Martian soil. NASA's carefully collected samples could contain microscopic fossils. Or, and this is equally important, we might discover that these organic molecules formed without life, teaching us that complex chemistry can arise through purely geological processes. That would transform our understanding of how common organic chemistry is in the universe and refine how we search for life elsewhere. But zoom out even further. China's roadmap isn't just about individual missions, it's about establishing China as the dominant space power of the 21st century. While NASA struggles with political uncertainty and ESA rebuilds from partnership collapses, China presents a unified, funded, aggressive timeline that extends to the outer solar system. The Venus atmosphere sample return in 2033 would demonstrate technology nobody else has. The autonomous Mars base in 2038 would establish Chinese presence on Mars before humans from any nation arrive. The Triton mission in 2039 would venture further into the outer solar system than any Chinese mission before, potentially discovering life in an alien ocean. What we're witnessing isn't just a space race. It's a fundamental reorganization of human space exploration. The old model of NASA leading while others follow is ending. We're entering an era of parallel development, where multiple nations and companies pursue different strategies simultaneously. China brings central planning and long-term commitment. NASA brings unmatched experience and scientific expertise. ESA brings international cooperation and advanced technology. Private companies like SpaceX bring radical innovation and cost reduction. Each approach has strengths and weaknesses, successes and failures. The rocket crash in Norway reminds us that space is unforgiving. The organic molecules on Mars remind us that the payoff for persistence could be extraordinary. China's roadmap reminds us that the future of space exploration will look very different from its past. Over the next 10 years, we'll see more missions to Mars than in the previous 60 years combined. We'll see the first samples returned from Mars's surface. We'll likely discover whether those organic molecules represent ancient life or complex chemistry. We'll watch China attempt things that sound impossible today. We'll see whether Europe can finally break its Mars curse. We'll discover whether NASA can maintain its scientific leadership despite political challenges. But most importantly, we might, just might, answer the question that defines our place in the universe: are we alone? The discovery of decane and dodecane in ancient Martian rock isn't just about molecules. It's about the possibility that 3.7 billion years ago, when Mars had water and warmth, microscopic organisms might have thrived in those alien lakes. Their cell membranes, made of fatty acids, might have broken down into the very hydrocarbons Curiosity just detected. So as China prepares to collect Venus atmosphere, as Europe rebuilds from rocket failures, as NASA analyzes organic molecules, remember that we're living through the most exciting period in space exploration history. Not since the space race of the 1960s have we seen such competition, such ambition, such potential for discovery. The next episode will dive deep into what these organic molecules really mean, how China plans to survive Venus's atmosphere, why Europe's rocket failed, and what all of this means for the future of human space exploration. Because whether it's China, NASA, ESA, or someone else entirely who makes the next big discovery, one thing is certain: the answers we're seeking are out there, waiting on Mars, in Venus's clouds, beneath Triton's ice, and in the data streaming back from our rovers, orbiters, and eventually, our sample return missions. The race isn't just to be first, it's to answer the biggest questions humanity has ever asked. And based on what we're seeing now, those answers might come sooner than anyone expected.